Okay, so you didn't get this question right, which is totally fine. That's what reteaching is for, and this is what these videos are for, to help reteach what you can't remember or don't fully understand. And as long as you're trying, you actually learn better from reteaching than always getting everything right the first go around. So let's do a little refresher. So what is an isotope? Well, let's take neon here for an example. So neon, if you look on the periodic table, you'll see that neon has a mass of about 20. Okay, so if you round that to a whole number, neon has a mass of 20. So that means this is the natural element. That's why it's on the periodic table as neon with a mass of 20. It'll have 10 protons, which is that top number you see on the periodic table. And then it'll have 10 neutrons and 10 electrons. Okay, so now with an isotope, the number of protons stays the same. Okay, so here is 2 isotopes of neon. And if you notice, the protons don't change. They stay 10 protons. However, that's 21. The mass changes. You notice it's no longer neon 20. This isotope is neon 21. And this isotope is neon 22. What changes its mass is that the number of neutrons change. So if you add an extra neutron, that's going to make the mass go up by 1. So if you add 1 neutron, the mass goes up by 1 because you're adding that weight. Okay? Now if you add 2 more neutrons, the mass will go up by 2. So instead of being neon 20, it's now neon 22. So the only difference with an isotope, these here, from their natural element, is that the protons stay the same, but the neutrons are different. You can either have more than the natural element, or you could have less. So we could see some going this direction instead of going this direction. So to recap, an isotope has the same number of protons as the natural element, just different number of neutrons.